Hello, my name is Carlos Rojas. I'm the Global Industry Solutions Lead for Manufacturing Solutions in Cisco, and I'm here together with Paul Didier, our IIoT Solutions Architect for Industry. Hi, Paul. How are you?
Hey, Carlos. Good morning.
Good morning. So we're here to talk about AI in industry, particularly in the manufacturing space. And with the background that we've had over the years, I think that AI is really taking hold in manufacturing, Paul. So I'd like to talk to you about what has Cisco done in order to enable AI in our customers, particularly in the manufacturing space?
I think we've been absolutely critical to AI taking hold in the manufacturing space. What's really required for AI, what's really driven AI into this space is the availability of data along with the compute platforms, and that data is accessible through the network Cisco puts in place.
Isn't the data already available?
Absolutely not. Typically in a lot of these manufacturing environments, what we see is use of what I would say is less capable network infrastructure and a lot of designs that are designed to keep either air-gapped or PLC-centric network designs to keep 95% of the devices and the data hidden from all of the rich ML AI applications that you'd want to apply.
So these are all together, these sources of data in a factory environment, for example?
So what we do with Cisco and our solutions and our, all of our technologies is we kind of like break that model. We kind of come in and connect all the way down, often into machines themselves, so that our customers have access to the rich data and devices that they deploy in their production environments. What's important, we supply the network in industrial formats that support all the applications that are running there. But it's Cisco, it's the internet. We can provide new data flows to these AI and ML applications that's critical to help bringing the AI capabilities to our manufacturing customers.
I've often heard that the sources of data inside of manufacturing are islands of data. So they come from many sources. They come from the MES system that you mentioned, they come from the historian, they come from individual servers that are on the factory floor performing certain functions, they come from sensor networks. So how is it that our designs that you talked about are helping with that particular effort?
Yes, so first we're able to put network infrastructure into the harshest, roughest areas, the smallest areas, into the machine, into these sensor networks. We support the applications that run on top of that, the automation and control, providing the resiliency, the deterministic qualities, working with the industrial, often a lot of the industrial application vendors and suppliers as partners, how to connect their applications up. So that's a really critical consideration, is being able to support the core applications that are there, but in a way that also allows that the rich data coming from a lot of these robots and sensors and actuators, drives, collect that data so that you can use it for your AI and ML applications.
But how is that different from how they collect data today? So this network data that you're talking about, network data flow, right? How does our infrastructure help, in accelerating that or changing that?
Yeah, so we break these models of these island designs that they've tended to use, either air-gap or PLC-centric, or whatever that kind of keeps a lot of the devices and the applications hidden. I've talked to OT people that use these in particular because they don't like the IT guys coming in, but that leaves them really handicapped from being able to use the AI and ML applications that the industry is starting to supply to them. They need access to the big data, and the big data is at the edge in these devices.
So we help with unifying the connectivity of all those islands. We help accelerate the data flow. But what about, but without disturbing the manufacturing operations that are necessary for their machine providers and their control systems that they have in their factory networks, respecting that.
Exactly. We even go to the extent where we develop our solutions with the input, with the applications from Rockwell, from Schneider Electric, from Mitsubishi, from even Siemens, to ensure that our network is going to support those applications, yet also drive a lot of this, the data flows into AI, ML type of applications.
I think that's a really good point where you bring up all the control vendors. These are existing vendors and suppliers inside the manufacturing operations that allow for machine control. So how is it that we actually do that? We're testing this, right? We're validated these interoperabilities.
We have the industrial Ethernet, industrial wireless, enterprise applications to connect all of that. We take all of this together with the actual devices and applications and test them and certify them, the validated designs that you were referring to, and make all of this public and provide training to our customers, to our partners on how to deploy these networks successfully. We give them the guidance and the directions and the implementation mechanisms to do all that. We're incorporating more of that into our Catalyst Center network management capabilities, but that's the rich way. We're not just the infrastructure, but the key solutions and management.
I remember when we first ratified the first version of that design many years ago.
Many years ago.
And was with only one control vendor, and now we have it with all those vendors that you mentioned. And it was only a 100-page document at that time, but today it's many hundreds of pages, and it's designed in a modular format so that customers can use it based on where they are in their digital transformation journey in manufacturing. So if they need a particular function because they're pretty far advanced in that journey, then they can go right to that module and they can use it. Or if they're just starting out, they could use it as a template. I've actually had customers take it, really scratch off the Cisco name, put their name on it, make a few changes, and they actually use it.
Yeah,
so we're essentially creating the easy button for this foundation for AI.
We want our customers comfortable deploying our technologies, our solutions in this space. So we'll do whatever it takes to help them develop the confidence to deploy these kind of capabilities.
So you briefly mentioned security. So tell us how this infrastructure and the flow of data, which is critical for moving data quickly and easily into the repository where AI is going to happen, the digital twin, the machine learning, et cetera. Tell us about the security component around what Cisco offers that's critical in there, and why.
Cybersecurity is so critical to this environment. If I go back and I was referring to air-gapped networks, I was referring to PLC-centric networks, and all of these things basically over the last 20, 30 years were successful at ignoring cybersecurity, generally speaking, totally ignoring it. So as we connect these things, a lot of the applications, the devices don't have a really strong sense of cybersecurity. And so what's really critical as we interconnect these environments is also to provide a lot of networking cybersecurity capabilities so that we maintain the cybersecurity, let's say, stands, improve the cybersecurity of the overall system. They want to pull a lot of data out, and that by doing that, it increases the security risk surface, so to say. But a good network design and networking capabilities can alleviate a lot of those risks by providing a lot of the cybersecurity within the network itself.
And I just want to be clear, I think we should add that all of our reference designs, our validated designs, are built in accordance to the NIST standards, as well as ISA 62443, which is a standard many of our manufacturing customers would understand and appreciate.
Yes.
And it's in compliance with the cybersecurity framework around 16 different industries. So I think that's an important statement, right?
Yes. We helped
build security in.
Well, we helped create a lot of those standards. As we've got a lot of cybersecurity capabilities, so we've helped create those. And yes, we have gotten our certifications and support a lot of the concepts and models that they specify and customers are looking for in their networks. Yeah.
That's awesome. So let me just transition to the Cisco AI tools. I'm going to use that little air quote because we now have AI tools that will help our customers with this digital transformation journey, accelerate that, as well as things that will help them achieve their own AI objectives and projects. Right. Can you explain some of the Cisco AI tools that are embedded in management and security?
Sure. So Cisco AI, we're using AI ourselves, like our customers are, to improve how our tools are used, to improve how our cybersecurity works in these environments. That's, I think, a really critical considerations. A lot of times in these environments, the networks are bought, deployed, and managed by operational folks, OT folks, as we like to call it. And they aren't necessarily the deepest in their networking or cybersecurity background. And so I think a lot of our AI tools built into our management tools, into our security tools, helps them a lot to deploy, use, monitor, manage, and maintain network and cybersecurity assurance in their environments. I think that's a really critical way to accelerate this IT-OT convergence, is by encapsulating a lot of that in the AI and ML and supplying it in our tool sets.
Well, I think that's excellent in terms of all the AI tools that we offer. We also offer AI tools that offer greater visibility, observability, if you will, right? So that people can action any anomalies that happen in the network.
Yes.
And they can, take it to the next level and probably apply policy to that, so that they can know, when that anomaly is coming up the next time, that they can get early warnings of that. And all of that translates to, and I think this is a very important point, day-to-day operations in manufacturing, absolutely critical. Uptime is king in manufacturing. It helps with maximizing productivity, it helps with maximizing throughput, it helps with overall equipment effectiveness. So we don't want the network to be the reason for downtime in a factory. So should there be an outage, AI and AI observability and visibility provide for the mean time to repair of an outage to be quicker, right? So we can apply policy to that, and we can learn the next time it happens a lot faster and respond even beforehand.
Exactly. One interesting point you brought up was, how our tools are also accelerating the AI adoption. And one of the most, if I wasn't excited about my job, our recent Splunk acquisition has really accelerated that too. We just bought a company that provides a lot of good observability, but it's also providing a lot of rich AI, not just for the network management. We use the AI tools in our Catalyst Center and our cybersecurity tools. But now with Splunk acquisition, we're able to cover a much broader area, and there's some really rich AI tools and capabilities that's going to bring and extend our reach, not just into the network, not just into the cybersecurity, but also help them, collect data from, the assets, the processes that,
day-to-day operations.
Day-to-day operations. And I think that's really going to extend our capability to help our customers adopt AI ML in their production environments.
I like to say that if I had Splunk when I was running my factories, I would have been a lot more successful at that time, but it's absolutely a game changer.
It is.
In terms of observability and the ability to apply AI functions inside the operations of what I think are massive networks inside manufacturing. If it's not just those islands, it's literally thousands of devices that customers have to connect and capture the telemetry from. So to manage that at scale is going to be challenging, and all these AI tools that you're talking about are going to help.
Yeah, this is such a wonderful opportunity. Most of our manufacturing customers have anywhere from 10 to 100 times as many devices in their industrial production environments as they do employees or people connecting to their network. There is so much more. There is so much more things to connect, data to use and analyze, and really improve, the manufacturing processes, and not just their manufacturing processes. We've got customers that are improving their products themselves through the data that they can collect on their manufacturing floors.
Okay, so let's talk about some examples of our customer AI projects.
Yes.
Right? So we'll talk a little bit about what we've seen so far, but also let's talk about what customers are thinking of going forward.
Yes.
Right? So there's generative AI and there's predictive AI. I would say let's start with predictive AI first. What are some of the basic projects that our customers are benefiting from an AI standpoint with all this new connectivity.
Right. So manufacturers have actually, AI is a big hype term today, but our manufacturing customers have been using ML, which is kind of lumped in with the AI,
Yeah.
for years, if not decades. As the connectivity has extended, we've been working on this for 15, 16
Right.
years, Carlos.
Yep.
As that connectivity is getting in there, some of the first things that they do is start driving machine learning applications on robots and machines and other parts of their plant to basically predict or give indication of when downtime is going to be occurring, when
Right.
something isn't operating at its highest efficiency. So they've been using that for years, and they're going to continue to do that.
Right.
As the network extends down, what we're seeing is that go even further, where they're collecting so much information, they're able to not just predict downtime or challenges within the machines that they've connected, but actually starting to predict what's the quality of the product that I'm building. How is my product the most,
Right.
being produced, manufactured in the best way, the most efficient way, the most energy-friendly way. In essence, sustainability. Their sustainability is a lot of times driven by the data that you can collect from the processes that you're trying to optimize, and that's what we're seeing is ever more networking and security going into these places, deeper and deeper into the networks, and they're able to then drive a lot better, more detailed AI and ML processes and improvement.
So predictive maintenance, predictive quality, and predictive sustainability. I've heard of the IDTA, which is the International Digital Twin Association,
Right.
which allows for marking the production of a product and providing a digital passport for its production.
Right.
And then the next time that product is manufactured, they'll be monitoring, how well they perform from a carbon footprint standpoint on the second time around of producing that product, right? So it's a baseline.
Right.
Digital twin is now becoming a baseline for sustainability manufacturing.
Right.
So that's great. Now, what about generative AI? I personally have seen a customer take an example, I'll throw this out there, of taking historical records of maintenance and equipment setup and loading that into a database and combining it with real-time information to be able to create a bot, a chat bot where somebody can actually call up information on a previous equipment setup or call up information on a equipment repair. And I think that's only possible if we have the real-time data combined with the historical records, right?
Exactly. Yeah. So I think the Gen AI stuff. We were at Hanover.
Yeah.
And there's a lot of discussion around AI. And when it comes to the generative, I think a lot of it's still in the early phases. It's, as you kind of said, I think it's being used to help people understand really complex systems, the chatbots, the assistants, you name it. But basically kind of give them a lot of the basic engineering material, and they provide really good AI. Where I think things, and I think that's really helpful. We're doing that as well in our tools, right? That's part of how our tools are
Evolving.
evolving
Yeah, right.
as well. One of the more interesting ones I heard of recently was one of the more challenging things they're using some of the Gen AI is training a robot, for example. Training a robot is a really long and arduous activity, where you basically have somebody with, if you want to call it that, a joystick that basically teaches the robot or tells the robot what are the actual movements and other things. Well, what they're doing is, you can feed a lot of that into the Gen AI, and it can understand, how best to program my robot, given certain, qualifications or characteristics that you want out of the robot movement, processing, the job that you want it to do. And so I find that seems like one of the more natural areas. For Gen AI to really get into the production environment, it's going to have to get closer.
What do you mean by closer?
So most of the things in a manufacturing environment are operating in cycle times measured in milliseconds, tens of milliseconds, things like that. And so for AI to really impact a lot of those environments, it can't be just in the cloud. It
Oh, I
has
see.
to kind
Closer to the edge.
It has to come closer to the edge to be able to process the data, but also come up with inferences and deliver those inferences back into the systems in much quicker timeframes than just in the cloud would enable.
Okay, that's great.
Yeah.
Well, this has been a great conversation, Paul.
Yeah.
Thank you for sharing all your insights. And it's been a great journey with you, as you mentioned, for many years in trying to build up our manufacturing practice. And I think a lot of customers are benefiting from it.
Yes.
Because these foundations not only help them achieve that Industry 4.0, faster decision-making process with more data, but it also is a platform from which they can build their AI projects. Because now they have all this data delivered in new data flows that won't take hours for people to download from a server in order to do a report or analysis.
Exactly.
Right?
You can create your AI application, run it on an edge cloud platform, tell the network, hey, this is there, I need data from here, there, and everywhere else in the plant floor. And that can happen in a very programmatic, very quick, in a software-defined manner.
So in summary, Cisco has built a set of reference architectures, a collection of ruggedized products that fit into the manufacturing environment, a set of design guides and best practices so that we don't interfere with the industrial operations and OT requirements of machine control, but that provide the connectivity layer that's necessary to extract the data. So we've created that easy button for our customers, and we're really happy that you spent a little bit of time with us. I want to thank you, Paul, for spending some time with us.
Don't forget the cybersecurity.
Oh, don't forget the cybersecurity.
That's a really
right.
critical
That's
point,
right.
but yes.
So it's important that you understand that we build cybersecurity into everything that we do, as well as offer it separately.
Yeah. Thank you, Carlos. This was a good discussion.
Yeah, it was great.
It. Yeah.
Nice to see you again. Thank you, everyone.
Thank you.